Right, so the questions you are to do for homework, it just says methane is the simplest hydrocarbon known to man. Identify the type of bonding present in methane, state a reason for your answer. So methane is CH4. What type of bonding do you think exists in methane? CH4. Covalent, that is correct. Now, why do you say it's covalent bonding? So it says state type of bonding, you said covalent, that is correct. Why did you say it was covalent bonding? Any reason? You're correct, it's covalent. All right, so we know covalent bonding occurs between two non-metals. Both carbon and hydrogen are non-metals. So if the two of them were to form a bond, it would be covalent bonding. And I already showed covalent bonding in methane before. So you're correct, it is covalent bonding. Reason, covalent bonding occurs between non-metals only. And both carbon and hydrogen are non-metals. Right? So that's the reason. Covalent bonding occurs between non-metals, and carbon and hydrogen are both non-metals. And then the next question it had said, methane, like other alkanes, is generally unreactive. However, under certain conditions, it can undergo reaction with chlorine, forming carbon tetrachloride. Write an equation, write a balance equation for this reaction. So it says methane, like other alkanes, is generally unreactive. And it can undergo reaction with chlorine under certain conditions. And we're to write a balance equation to show this reaction. So the equation that they're asking us for is methane reacting with chlorine to form CCl4, right? But we know that in this equation, what is missing from over here? What should be
hydrogen.
HCl, right? Not just hydrogen, but HCl, all right? So that's the equation. Methane can react with chlorine to form carbon tetrachloride. But we must also remember that in this reaction, we also get HCl. Right? So all we need to do now is balance the reaction and the equation. So we have carbon, hydrogen, and chlorine, right? On both sides of the equation. Carbon, hydrogen, and chlorine. We know we only have one carbon on both sides of the equation. So we have one carbon on both sides of the equation. How many hydrogens do we have on this side of the equation?
4.
Right. And how many do we have on this side?
1.
All right. So what times 1 will give a 4?
4.
All right. So we need to put 4 in front of HCl. How many chlorine do we have on this side?
2.
All right. How many chlorine do we have on this side? All right, how many chlorine do we have here?
5,
Hold on, how many chlorine do we have here?
4,
4,
sir.
4,
Right. And how many chlorine is present in HCl? 1,
1,
right? But what is in front of it? 4.
4,
Right, so you have to say, when you remember, when you have a number in front of the compound, it goes for all the atoms in the compound. So it's 1 atom of chlorine times 4, so that's 4, plus the other 4 chlorine in carbon
8,
tetrachloride. So that's a total of
8,
8, right? So we have 8 on this side and 2 on this side. So 2 times what will give you 8?
4,
4 is correct. And so we need to put a 4 in front of this chlorine, all right? So that's our balanced equation. So for those of us who are just joining, working the question that I had given at the end of last week's class for homework. This is from 2016. Question number 5, 5B from the 2016 past paper, where it asks us to write a balanced equation to show the reaction between methane and chlorine to form carbon tetrachloride. Or we can say tetrachloromethane. Now, something is missing. When this type of reaction is occurring, what should we ensure that we include? What should you put over the arrow? Anybody remember? So this reaction, it will not progress unless something is present.
Sir, heat, sir.
Right. I would say UV light. All right. So, so if you put sunlight, it's okay. Or you can put UV light. All right. So right. So this reaction, I think I'm going to do it at school and upload it. All right. So you just mix the two of them, but you do it in sunlight. So you would carry it in the sunlight, and it would proceed. All right. So the next question, it was basically asking for this. So it says, state the type of reaction taking place and identify the reaction conditions. So the UV light, that would be the reaction condition. What is necessary for the reaction to occur? All right. So the condition is UV light. Remember, the name of this reaction is halogenation of alkene. All right. And it's a substitution reaction. So it's halogenation. Halogenation. All right. So this not there. All right. And sometimes they also refer to it as a substitution reaction. Right? Because the chlorine, as we know, is substituting the hydrogens. Right, so that was 2016, number 5A and B. All right, let me look for our next one that we can answer based on what we have covered so far. I can erase this. Is anybody writing? These should be hydrogens where I have lines, all right? So this is compound A. Again, these are hydrogens, but when you're on the exam, don't do it like this. Ensure you put the hydrogens. All right. So this is compound B. And the question is, name the whole molecular series. This is also, right, this one is 2015, number 3. So this question is from 2015, number 3. All right, so this is 3A. 3A. It says, name the whole molecular series to which compound A and B belong. So which whole molecular series does compound A belong to?
Alkene.
Alkane. And which one does compound B belong to?
Alkene.
All right, so I said this was alkane and this is alkene. Now tell me how you know it was alkane and alkene. So how you know this one was alkane?
Single bond.
Because
Right. Only carbon to carbon, single bonds. All right, so if I had asked, what is the functional group for this compound? What would you tell me? What is the functional group for compound A and B? Tell me. No, the CHE, no, that wouldn't be a functional group. So remember, the functional group is what you use to identify each molecular series. So the person has said single bond, but they must say carbon to carbon, single bond. All right? So for alkane, the functional group is the carbon to carbon, single bond. So if you look at the compound, all the carbon to carbon bonds are single bonds. So that is an alkane. And if you look at this one, what would be the functional group for the alkene?
The C double bond C.
Right. So the functional group for the alkene is carbon to carbon double bond. All right. So you have to know the molecular series, functional group, and general formula. So with that said, so the past paper, it only asks you for the whole molecular series for compound A and B, but it could have asked you for the functional group as well. And the next thing I'm going to ask you for is the general formula for compound A. What is the general formula for compound A? I will just start it off with the Cn, and someone can finish it. So Cn, what comes next? CnH2n plus 2, correct. So material type CnH2n plus 2, so that is correct. And what is the general formula for the alkene?
CnH2n.
That is correct. So for the alkene, it is CnH2n. So these are simple 1 mark questions that you don't want to lose, right? So always ensure that you remember the functional group, the general formula, and the whole molecular series. All right. Now the next actual question from the past paper, other than to identify the whole molecular series, it was to state the name of each compound. All right. So what is the name of compound A? So this is compound A. What is the name of it?
2-methylbutane.
That is correct. So remember, we always identify our longest chain. And in this case, it's 4 carbon. All right, and we know 4 carbon is butane. All right. Now, we see that there's a CH3 group that is not a part of the chain. And when you have a CH3 group that is not a part of the chain, then that is called methyl. So it's not just butane, it is methyl, the branch group here, the CH3 group. So that's methyl butane. All right. And then we have to tell which carbon atom within the chain the methyl group is on. And counting from this end, because the methyl group is closer to this end, so we know it's 2-methyl. So the person is correct. It is 2-methyl butane. All right. For the alkene, we soon got the name in alkenes. But just like before, you will count the amount of carbons in the longest chain. So that's 4 carbons. So it won't be butane because it's an alkene. So the ending will change. It will be butane. Right. Now you look at which 2 carbons the double bond is located. So if it is in the middle, so we start counting from here. This is carbon 1, this is carbon 2, 3, 4. So the double bond is between carbons 2 and 3. We will give it the lower number. So it's 2. So it will be 2-butene. All right? We can also name it as but-2-ene. All right? So you can put the number between the first part of the name and the last part. So it will be but-2-ene. And you can put the number in front of the name, in which case it will be 2-butene. So we will do some more alkenes once we start on alkenes. All right, so part B of the question, it asks us to define structural isomerism. Can anybody tell me what is structural isomerism? All right, so remember isomerism, this occurs when 2 compounds, 2 or more compounds of the same molecular formula, but different structural formula. And so isomers of the same molecular formula, but different structural formula. All right? So structural isomerism, right, is when the arrangement of the 2 atoms or the arrangement of the carbon atoms in the 2 compounds are different. Right? So the compound they gave us, let's see which one they asked us for. They are fully displayed, they are the displayed structure of one structural isomer for each of compound A and B. So compound A, so we know compound A was 2-methyl butane. That was compound A, right? So a structural isomer, we must change how the carbon atoms are arranged in the compound. Can anybody tell me the name of a structural isomer for 2-methyl butane?
One methyl butane.
If I put, just a second, if I put the methyl group at carbon 1, so these are the 4 carbons, right? Let me just put this in block so you can differentiate. So you said 1-methyl butane, right? You're telling me to put the carbon, the methyl group, and this carbon. If I do that, what is this compound? And let me do it like this. Good. What would be the name of this compound? Is it 1-methyl butane? Can we have a methyl group at carbon number 1 at the end?
No.
No. So remember, we always said that if we're taking a methyl group from somewhere, we cannot put it at the end. Now, since as it is here, what is the name of this compound?
Is it isobutane?
So would it be pentane?
Also pentane, that is correct. So remember now, you see this structure here, it's the same as this one. So this CH3 group, this is it right here. C, a carbon with 3 hydrogens. That is why we say a methyl group can never be at the end of a chain. We call it methyl. It's called methyl when it is attached. It's like how this is our chain with the 4 carbons here, right? So the methyl group is not a part of the chain. That is what we call it methyl. The CH3 group is not a part of this chain, right? So we don't call it, that is what we call it, methyl. But if you tell me to put it on carbon 1, not because it's pointing upwards makes it methyl. Because being attached to carbon 1, it can be in any of the position, whether above, below, or to the left, it is still attached to the first carbon, right? 3 hydrogens. Do you understand the difference when you put it at the end? Even if it's here or below, it is still attached to carbon 1. Well, this wouldn't be carbon 1 anymore. This is carbon 1. All right, so you could not do that. So the person that said pentane is correct because it's 1, 2, 3, 4, 5 carbon in a straight line. Now, if you wanted the next isomer, what we normally would have done, right? We would have got the pentane, and then we would have removed the carbon from the end. And we would have 1, 2, 3, 4 carbons remaining, which is this. And then the methyl group, we would not put it at the end because you would be getting back the same thing, which is what I had pointed out when we were doing isomers. If you take off a carbon at the end, do not put it back at the carbon at the next end. It must go on a carbon in the middle, all right? Which is what happened here. But because we start out with this, then you can come and draw the straight chain as an isomer. So both of these are isomers. So if they give you the branch version of the isomer to start out with, you can always go ahead and draw the straight one. All right? So they give you 2-methyl butane. Pentane is an isomer. So this is pentane. This is 2-methyl butane. And I told you there were 3 isomers for pentane. What is the next one? So we have pentane, 2-methyl butane. What is the third isomer? So C5H12, that's the molecular formula. It has 3 isomers. Pentane, 2-methyl butane. Anybody remember the third one? All right, so this is what you should do. You remove the next carbon from the end. So if we remove this carbon, we have 1, 2, 3 more carbons in the chain. 1, 2, 3 carbons. And remember, we cannot put the carbons that we take off at the end. We are going to get back the compound. So remember, this methyl group was already on this carbon. So when I take off this carbon, you can only put it on the middle carbon, right? One of the carbons inside the 2 N carbons. All right, so you can only put it on this carbon. All right. So what is the name of this compound?
2,2-dimethyl propane.
That is correct. So the 3 carbons, that is our main chain. And if it's 3 carbon, it is propane. Now, this methyl group is not a part of the chain. This methyl group is not a part of the chain either. So once the CH3 group is not a part of the chain, it's called methyl. And if you remember the rules for naming compounds, when you have 2 or more of the same substituent group, we use prefixes. Say because we have 2, we use di. So it is dimethyl. If it was 3 of them, we use tri, 4 is tetra. Now, both of these methyl groups are on the second carbon. That is why we put 2, 2, dimethyl, because we are telling the position of both of them. So both of them are on carbon 2, so we say 2, 2, dash dimethyl propane. All right? This carbon, this CH3 group right here, let me just, it probably can clear up something. If I should write the condensed formula for the CH3 group here, right? This would be it. And if I erase this and write it as CH3, all right? This says CH3, right? This is CH3 as well. But they are not methyl groups. Even though it says CH3, it is not a methyl group. Can somebody tell me why we would not call this one methyl? Why would we not call this one methyl?
Because it is a part of the main chain.
Exactly. So this is what I'm saying. Once it is a part of the main chain, we don't call it methyl. Good? You're going to count it, and you're going to say 1 carbon, 2 carbon, 3 carbon. All right? You're not seeing methyl. Once you count them out now, that is the chain. You will look outside of the chain and see if there are any groups other than hydrogen that is attached. And we see a CH3 group outside of the chain, and we see a next one here. So that is why these 2 are called methyl, and this is not, because it is part of the main chain. But these 2 are attached to it, and that is why we call them methyl. We have 2 of them, so it is 2,2 dimethyl propane. Remember these 3 isomers, all right? CSEC if isomers are coming, it's most likely pentane or butane if it's an alkene. So just remember pentane has 3 isomers, all right? Pentane 2-methyl butane, 2,2 dimethyl propane, all right? The past paper question, however, it had just asked for 1 more. So you could do this or this as the isomer for 2-methyl butane. Right, just a second. Let me plug in this. All right, so we're going to start alkenes now. Is anybody writing? All right, so for alkenes, we already went through the general formula, functional group, and we know the whole molecular series is called alkene. So we're going to start with naming the alkenes. Remember, carbon only form 4 bonds. So when you get to the double bond, careful how many hydrogens you put on. Because if you do this, it is incorrect. Because this carbon would have 1, 2, 3, 4, 5 bonds. Remember, this double bond is called double bond because it is literally 2 bonds. So that means you cannot put this here and this cannot go there. All right? So 2, 3, 4, 1, 2, 3, 4 bonds. So 4 carbons, remember, the prefix stays the same. Any amount of carbons you have, it doesn't matter which whole molecular series we are dealing with. The prefix, so bute, pro, pent, it stays the same. So once you say 4 carbon, we know it is bute. All right? It's an alkene because of the double bond, so we know it is butene. The only thing we need to do now is to tell where the double bond is. When we are counting, we count from the end closest to the double bond. That means we would not count from this end because this carbon is closer to the double bond. So that means this would be carbon 1 and this would be carbon 2. So the double bond is between carbon 1 and carbon 2. So you're going to give it the number, you're going to give the double bond the number that is lower. So it's between 1 and 2, 1 is of course lower. So it is 1 butene. Again, you can say but 1 ene. So you separate the 2 parts of the name with the number in the middle.
So, sir, suppose the double bond was in the middle.
Please repeat, if it was here.
Yes, sir.
All right. 1, 2, 3, 4. All right, how many carbons are there?
4.
All right, so that's butene again. We have 4 carbons, and obviously the double bond is in the middle. That means, all right, let me show you. If we start counting from this end, this is carbon 1, 2, 3, 4. If we start counting from this end, carbon 4 becomes carbon 1, carbon 3 becomes carbon 2, then 3, and 4. This is the left hand side, this is the right side. So counting from the left hand side, right? The double bond is between carbon 2 and 3, right? So that's,
Yes, sir.
and if we're counting from this end, the double bond is also between carbons 2 and 3, right?
Yes, sir.
So in this case, it doesn't matter which end you count from because it is in the middle. All right?
Sir, so will that always end up to be 2 butane?
Right. So it's 2 butene. You always choose the lower number. So
Yes,
between
sir.
carbon 2 and 3, so we say 2 butene, or what could have been the other name?
But 2
Yes,
ene.
that is correct. We say but 2 ene. All right? So I'll give a little time to write off that, and then we'll do some more. All right, I'm going to put a chlorine here, Cl group, right? So again, this would be but1e. So when you have, let me make this clear now, you have a substituent here, and you have the double bond. Unlike in the alkanes, where you would count from the end closest to the group, not with the alkenes. With the alkenes, the double bond takes preference, or it gets the preference. So you always count from the end closest to the double bond, not the other group that is attached. So in this case, which end should we count from? The end closer to chlorine or to the double bond?
Sir, right side.
That is correct. Because the double bond is getting the preference. So for carbon, when it's but1e. So but1e, the double bond is getting the preference. That means the chlorine is on carbon number 3. So it is 3-chloro but1e. Or if you want to say 3-chloro 1-butene. Alright, but the important point to note here, when you have a next group on the alkene, the double bond still get the preference, not the group that is attached. So that is where the chloro group, it's carbon 3, and we don't say carbon 2. Alright.
I don't about to talk.
No man. What is the name of this alkene?
One pentene.
That is correct. Pentene. Finish it up here now?
Yes, sir.
Alright. What would be the name of this alkene? Anybody?
Sir, 2-methyl,
Mm-hmm.
2-propene.
All right. Where is a 2-propene? Okay. Just a second. Let me highlight the chain. This is the chain, right?
Yes, sir.
So the double bond, it would be between carbon 1 and carbon 2, right?
Yes, sir. So yes, sir.
Yeah, man. So it would be 2 methyl, 1 propene. And all right, we're going to convert these displayed formulas into condensed formulas because sometimes you will get the condensed formula for the alkene. So I'm going to do 1 pentane first, then I do propene. All right, so just as usual, let's just separate the carbon atoms. So starting with the first carbon, what is attached to the first carbon? How many hydrogens?
3.
All right, so CH3. Then this carbon, what is attached to this carbon?
1.
And 1 hydrogen. Then this carbon, what is attached to it?
2.
All right. Then we move to this carbon, and we have 2
2.
hydrogens. Right? And this
3.
one, that is correct. Now, when you get the condensed formula like this, remember every carbon must have 4 bonds. If you get an alkane, when you have the condensed formula, if it's not substituted, like with a chlorine or a methyl group, there should be no CH bonds. You should have CH3, and then everything between the two CH3 groups should always be CH2. Once it's a CH, it means that the carbon is not forming 4 single bonds. What you can also do when you get the condensed formula, count up the amount of carbons present. So if we do this, 1, 2, 3, 4, 5 carbons. So the molecular formula is C5. And then I count up the hydrogens. 3 and 1, 4 and 2, 6 and 2, 8. That's wrong. 3 and 1, 4 and 2, 6 and 2, 8. Tell me what is wrong with this structure. So let me write, based on what I have here, I have C3H11. What is wrong?
We're missing that H.
Not missing? Is it missing or we have too much?
Sir, 1 extra.
We have too much. Look at this carbon here. And I pointed it out earlier. When we're doing the alkene, we have to pay careful attention where the double bond is and ensure we don't put too much hydrogens. This one of the hydrogens should not be there because the hydrogen that was here, it would mean carbon is forming 5 bonds. 1, 2, 3, 4, 5. And remember we say carbon form 4 bonds. So this should have been CH2. Because if you notice, C5H10, I
Sir,
mean
repeat that,
C5,
please.
all right,
Why there's isn't any H at the bottom of those
all right.
two?
So carbon is tetravalent, 4 bonds it form, right? But if you look at this carbon, how I have it now, the double bond, that's 2 bonds, plus this 3, 4, and the one at the top that makes 5. So I cannot have carbon forming 5 bonds. It forms a maximum of 4. So that means this carbon have too much hydrogen. So one of them must come off. Any one. Alright, so it could have easily just took off this one. Alright? And how I picked it up was from this. Neither this C5H11, it doesn't fit alkane and it doesn't fit alkene. Because for the alkene, if it has 5 carbons, it must have how many hydrogens? Remember the general formula? CnH2n, right? The amount of hydrogen must be twice the amount of carbon. So if it's an alkene with 5 carbon, it must have 10 hydrogen. If it was an alkane with 5 carbons, how many hydrogens should it have? An alkane with 5, 12, right? So C5H11, that doesn't fit anything. So I made a mistake. That is why I came back and looked. All right. So when you're joining alkene, right? So the condensed formula is CH2, CH, CH2. All right. So if you get the condensed formula, you will just work out the molecular formula. And from that, you know if you have an alkene or an alkane. So in our case, if I gave you this, right, and told you to draw the displayed formula, just write the molecular formula first. And we can see that it is C5H10, so we have an alkene. All right. So let me erase the alkene, the displayed formula. All right. So starting with this, we have CH2. So let us draw CH2. All right. That's the first carbon. It has 2 hydrogens. So this carbon is attached to this one. And this one, it only has 1 hydrogen attached. So even with the condensed formula, you can separate the carbon atoms. All right. So this carbon has 2 hydrogens. This carbon has 1 hydrogen. This carbon, it has 2 hydrogens. This carbon, it has 2 hydrogens. And this carbon, it has 3 hydrogens. All right. So when you do this, check your compound and see if every carbon has 4 bonds. Remember, all your carbon atoms must have 4 bonds. So just check for me. Does all the carbon atoms have 4 bonds?
Everything except for the 2 nitrogen.
Exactly.
2 carbon then.
Right. So the 2 carbon atoms that are short, it means that they need a double bond. So based on the condensed formula, we wrote the molecular formula and saw that it was an alkene. So we need to know where to put the double bond. So you did the check and you saw that these 2 carbon atoms were short of 1 bond. Because this carbon, it has 1, 2, 3, and this carbon, it also has 1, 2, 3 bonds. So I'm going to put a double bond, a next bond right here. Good? So this is where you will put the double bond. And now this carbon, it has 1, 2, 3, 4. And this one, it has 1, 2, 3, 4. So they can give you the condensed formula, and you have to figure out if it's an alkene or an alkane. So I would just suggest you write the molecular formula first, and that will, off the bat, tell you if it's an alkene or alkane. Then when you draw it now, you will check which carbon does not have 4 bonds. And you put the double bond between those 2 carbons. All right, so draw this and then work out this one. And remember, do not do like me, put on your hydrogens. All right, so let us do this one now. So again, pay attention to the carbon in the main chain, not what is attached. And let's separate them. So we have carbon with 3 hydrogens, so that's CH3. Then we have a second carbon, and to the second carbon, we don't have a hydrogen, so we cannot put CH, right? What we do have is a CH3 group. So you can write CH3, right? But you put it inside a bracket, all right? So what this means is that this CH3 group is attached to the carbon. Now, even if you don't see it in a bracket, right? When you're writing the carbons, right, in the condensed formula, it's always you always have carbon to carbon bonds, right, in the main chain. No, no. Have you ever seen a CH3 group within the main chain, like between 2 carbon atoms as part of the main chain? So like, have you ever seen this? Like so CH2, right? And in the middle, you have a carbon with 3 hydrogens, and then CH2. Have you ever seen this?
No, sir.
No, right. So what I'm saying, if they gave you the condensed formula, and you say CH3, C, then CH3, and after the CH3, you see CH2, or anything afterwards, it means that this CH3 group is a substituent, because as I've pointed out here, it cannot be a part of the main chain. The only time CH3 is a part of the main chain is if it's at the start or at the end, but not in between. So once you spot a CH3 group in the condensed formula, if it's not at the start or at the end, it's a substituent, means it is attached to the main chain, right? But sometimes they will make it easier for you and just put it inside a bracket to signify that it is not a part of the main chain. But I'm saying, even if you don't see a bracket, you know that the CH3 group, it's either going to start it or end it. Once it's in the middle, it means it is attached to the carbon before it. So this CH3 group, it is attached to this carbon. All right? So the condensed formula, let's go again. We start with the carbon at the front. 3 hydrogens are attached to it. We come to the middle carbon, no hydrogen is attached to it. What is attached is a CH3 group. So you write CH3, and then you move on to the next carbon with two hydrogens. Is that clear? Any question? All right. So this is how you would do the condense. Let me erase the displayed one and do it now. So we just draw the condense based on the displayed. Let's look at the displayed and draw the condense. So again, if you got this, no, if it was an alkane, it cannot end with CH2. All right, alkanes always end with CH3. But let us look at the molecular formula. How many carbons are present in total?
3.
No, in total. Count
Oh,
everything.
4.
Right. So the molecular formula is C4. How many hydrogens?
8, sir.
8.
Right. So C4H8, does this molecular formula, does it match the general formula of alkane or alkene? Alkene,
Alkene.
right, right. So this is an alkene because we work out the molecular formula and we see that it matches the general formula for the alkene. So we know we are drawing the displayed formula for an alkene, which means that somewhere in there must be a double bond. So let us try and figure out where. So starting with this carbon. So you draw the carbon, you put on the three hydrogens. Then you move on to the next carbon. All right. We see a CH3 group, right? We cannot have CH3. All right. We cannot have CH3 and then dash CH2. Because remember, carbons are connected to carbons in the chain. Hydrogen cannot be in the chain. So just pointing that out. So when we get to the CH3 group, we know that it cannot be within the chain, right? It must be attached. So you can put it above or below, whichever you prefer, but it must not be within the chain, all right? And then now we have afterwards, we have CH2, and we finish. So we did the CH3, we did the carbon with the CH3 group, and note you don't have to condense the CH3. All right, you can draw out the hydrogens if you want. So you can draw out the three hydrogens. All right, so you don't have to put CH3. You can write the carbon and write out the three hydrogens. That's okay as well. All right. So that is the CH3 group right there. So the next thing we must do, right? Remember we said it's an alkene. So a double bond must be somewhere. Your job now, check which carbon don't have four bonds.
Sir, the last one.
This one and the middle one, right?
Yes, sir.
Right. That means a double bond must go there. Alright. And there have the displayed formula for your alkene. So that is how you go from the condensed to the displayed and vice versa. Alright. Anybody still writing? So let's do isomers for alkene. We're going to start with butane, so C4H8. I mean butene. With the alkene, it's a little different from an alkane, as in the type of isomer that you can get. So I'm going to draw 4 carbons, right? Put the double one there. This is a bit double. So this here we have one butene. To get an isomer, all you have to do is move the position of the double bond. So if you have one butene and you move it, you can get 2 butene. All right. So both these structures are isomers. All you have to do is move the double bond to a different position. Question, is this, what is the name of this alkene? So I put the double bond out here. What is the name of this alkene?
Propene.
Please repeat.
Sorry, is it
Sir,
propene?
butene.
Right,
Same thing.
but which number would it be?
One.
Right, because we would have to come from this end. So this is still one butene. All right, so when I say moving up the position of the double bond, it can be here and it can be here, but you cannot put it here. If you put it here, as you can see, the name of the compounds are the same. What you basically did was flip the molecule. So even though when you're writing it on the board, it looks like you're moving the double bond from here to here. If you had the molecule, you would realize that all you did was flip the molecule. So you did not change anything in it. All right. So even though it looked like a move, the double bond from here to here, actually you just flip the molecule. So you didn't actually move anything, even though it appeared that way. So once you see the names are the same, it's not an isomer. So you have one butene and 2 butene. These two are isomers. This one is the same thing as the first. All right. These two could work as isomers, because it's one butene and 2 butene. But you cannot have these two, right? Because they're the same thing. And again, please put on your hydrogens. You will lose marks. And don't just do this either. Actually, write the hydrogens. Now, once you have done this, you do what you normally do for the alkane, which is you go to the end of the compound and you remove a carbon. All right. So with the isomers for alkenes, you can move up the double bond. That's first. If you want the next isomer, you just go to do what you normally do for the alkene. All right. So let me just erase these two and do it with this. So if I remove this carbon, then I would have 3 carbons remaining. 1, 2, 3. A double bond must be there. You can put it anywhere, right? The methyl group, can I put it out here?
No, sir.
It must always go here.
In the middle.
All right. So there I have it. Mhm. So what would be the name of this alkene?
Sir, 2-methyl 1-propene.
Correct. 2 methyl 1 propane, or 2 methyl. Just as a reminder, you can put the number between it's 2 methyl prop 1E. Alright? So for alkenes, it's pretty easy. You just move the double bond to different positions, or you do what you do for alkene. Take off a carbon and put it somewhere in the middle. Alright? So it's time to move now to the reactions of alkenes. Just a second. All right, so we're going to look at the reactions of alkenes. So this, so we're looking at ethene. All right, so this is an example of our alkene with the double bond. So this is the double bond. These are the carbon atoms, and the white ones are the hydrogens. So this is C2H4. All right.
Sir, can you come over a little bit more, please?
Over here, this side.
Yes, sir. We can see it now.
All right. So this is the ethene, the 2 carbon atoms with the double bond in the middle. And these are the hydrogens. Now, alkanes, when they are reacting with halogens, remember, in order to put on like a chlorine and the alkane, we had to remove a hydrogen because we said the carbon, it formed 4 single bonds, right? So when you have the 4 hydrogens, you cannot put anything on it unless you remove a hydrogen. So that is why we said the characteristic reaction of alkane is substitution, because you have to take off a hydrogen to put something on it. So carbon has 4 single bonds, and also the next word we use, we say the alkane is saturated. All right. So because it forms 4 single bonds, right, and it cannot form anymore, we say it is saturated. The alkene, because of the double bond, it is said to be unsaturated. Unsaturated because of the carbon to carbon double bond. And so just remember that alkenes are unsaturated because of the carbon to carbon double bond. Alkanes are saturated because they form carbon to carbon single bonds. Well, not just carbon to carbon single bonds, but single bonds in general. All right, 4 single bonds. That is why they are saturated and do substitution. Alkenes are unsaturated and they do addition reactions. So it's addition for alkenes versus substitution for alkenes. Right? So let me show you why we say it's addition for alkenes. what is going to happen, right? When an alkene reacts, just a second, I will do this. So let's say this is a halogen, right? With a Br2Cl2. This is an alkene. When an alkene is going to react with any other reagent, the double bond is going to break. The double bond is going to break. All right? And this happens. Good? So the double bond, it breaks. So the carbon to carbon double bond that existed before, it breaks. And so, you know, of carbon to carbon, single bond. So let me put that on the board. And let me erase this part. So you make the note already, right? It's addition for alkene versus substitution for alkane. Alkenes are unsaturated, alkanes are saturated. So you have the alkene before, when you react it with, say, we're going to use Br2, right? What is going to happen is that the carbon to carbon double bond is going to break. All right, let me highlight it with a blue. All right. So the blue is the double bond. So it's going to break. All right. So let me put back the black now. All right. So when you react the alkene with any reagent, one of the bonds in the double bond is going to break. So you will end up with carbon to carbon single bond. So immediately you are converting the alkene into the alkane. So whenever alkenes react, the double bond is broken and is converted to a single bond. All right? So what is going to happen now? Remember we said the characteristic reactions of...
Repeat
Go
that,
ahead.
please.
So when we react the alkene, the double bond is going to break. And whatever we are reacting the alkene with, it is going to be added to both carbons of the double bond. So let me show you here first, and then we'll go back to this. So you have the carbon to carbon double bond here. We want to react it with Br2. The first thing that is going to happen, the double bond is going to break. Now, which functional group is carbon to carbon single bond? Which homologous series has carbon to carbon single bond?
Alkene.
Alkane, right? So that means we start out with an alkene, right? But during the reaction, it is converted to an alkane because the double bond is broken. And so we will have carbon to carbon single bonds. We say alkenes undergo addition, right? That means we are not substituting any of these hydrogens that were there. That happens in alkane. It means that we're going to add something to the alkene. Now remember, all of these holes in the, we have 1, 2, 3 of them, right? They represent where bonding can take place, right? So the Br2, they are going to separate. Good. One of them is going to come to this carbon, and the next one is going to come to this carbon. See that? Understand?
Yes,
Sir,
sir.
can go back again,
No.
please.
Sure. So this is Br2. This is the alkene. During the reaction, right? So you see at this level, all we do are equations. So we just tell you that the alkene will react with bromine, and then you'll get the products. At the Cape level, we will do a stepwise process that shows you what happens. That is called the reaction mechanism. All right? So what will happen? The two bromine atoms, right, in the Br2 molecule, they must be separated. All right? So the bond between the two bromine atoms will break. So the bromine atoms are apart. The double bond, that must be broken as well. So we convert it. When it is broken, it is converted to carbon, single bond now, right? Because the bond is broken. And remember, the two bromine atoms are now separated. So one of them is going to bond to this carbon, and the next one is going to bond to the other carbon. So nothing is being substituted. What are we doing? Adding. Is that any clearer?
Yes, sir.
So we have just added Br2 to the alkene. However, when you look at it, do you see carbon to carbon double bond?
No, sir.
No. That means it's an alkane now. So when we react the alkene with certain reagents, it is converted to an alkane. The next important thing, two things are always added to the alkene, and we put them to each carbon of the double bond. So you notice the two bromine atoms, they did not go to just one carbon atom. One came to this one and one came to this one. So we are always adding things to both carbons of the double bond. I'm going to add a next carbon to make a next point. So let me remove this. Just a second. All right. So this is 1-propene. All right. The reaction of alkenes, it takes place at the double bond. So ignore the other carbon atoms. All right. Let me put on the next one. The reaction is taking place between the two carbon atoms of the double bond. This carbon atom, nothing is going to happen to it. This carbon atom, nothing is going to be added to it. The reaction is taking place at the carbon to carbon double bond. So let us go again. We have Br2. When we say we are reacting it with the alkene, it doesn't matter how long the chain is, where the reaction is taking place at the double bond. So again, the double bond is going to be broken. All right. A bromine is coming to this carbon of the double bond, and the next one is going to this carbon of the double bond. You notice nothing happened to this carbon here, nothing happened to this one, because the reaction only takes place between the carbon atoms of the double bond. So as an equation, when ethene reacts with Br2, Br is coming, one Br comes here, one Br comes here. That's the reaction. Ethene reacts with Br2, you will get 1,2 dibromoethane. So you realize that none of the hydrogens were substituted. All we did was add two bromine atoms to both carbons of the double bond. Is that clear?
Yes, sir.
Sir,
Yeah.
when you for that alkene,
Mhm.
sir, when you do the reaction, it turn into an alkene basically.
Right.
So you can do
Because
this when it
please
turn to
repeat.
alkene, you can do the substitution reaction too.
Exactly.
Oh.
Right. So once right. So if you react the alkene with this, right, and you get 1,2 dibromethane, this can go ahead now. So if we should react this with bromine again, what would happen now? So if we should react this with bromine, what would happen?
So hydrogen them will go get kicked out.
Exactly. Good. Because this is now an alkane, and alkanes undergo substitution. So one of the hydrogens, let's say this one, it would get replaced with Br. So one of the hydrogens would get replaced with Br. So this is now substitution, and then you would get HBr. I'm glad you pointed that out, right? Because after we do alkanes, alkenes, alcohols, we have a part that we make a reaction scheme where we convert one thing to the next and another, right? So like how we react the alkene with bromine and we get the alkane. If you react the alkane now with Br2, the reaction will be different. It becomes substitution, just like we did with the alkane. So one of the Br would replace the hydrogen and they get HBr. So you realize when the alkane reacts with the halogen, you get two products, right? This is one, this is the next one. However, when the alkene reacts, how many products do we get?
One sir.
One. Because we're doing addition. So all we're doing is adding things to the molecule. So we only end up with one product. So whatever you react it with, we're adding. So if you use Br2, you just put one bromine atom on each carbon of the double bond. Right? So this is the first reaction of alkenes. It's halogenation. Once you react it with an halogen, it's halogenation. All right. Now, unlike alkanes, you don't need UV light. You just react the bromine with the alkene and the reaction occurs. All right. Make a note. The observation, the bromine will be decolorized. So when you react the alkene with bromine, the bromine will be decolorized. So that's your observation. So just make a note at the same time. And the next note you should make, UV light is not necessary for this reaction. You can just carry it out in a lab. And this reaction, I will tell you from now, it is one of the reactions that we use to distinguish between alkenes and alkanes. Because this reaction will occur in the absence of UV light. But for the alkane, it will only occur if UV light is present. So if you want to differentiate between the alkene and the alkane, you just add some bromine water to the alkene and the alkane inside of the lab. The one that decolorizes bromine is the alkene. The one where no reaction occurs is the alkane. Because remember, the alkane, it needs UV light. So you would carry it outside in the sun, make it take place. All right.
So, sir, all alkane solutions has to have UV light for it to react.
Right. If it's this type of, if we're doing this type of reaction, halogenation, it
Yes, sir.
needs, right, it needs UV light, else it won't occur. All right. But the alkene, it don't need it. So this reaction here, this is a reaction we use to distinguish between alkenes and alkanes. A test, you just add a small amount of bromine water to the alkene and the alkane. That's it. All right. Here, observation: the alkene will decolorize the bromine. All right. So the next reaction now. So the first reaction is halogenation. We react it with bromine, which is a halogen. The second one, the second reaction is with HBr.
Sir, what is the name of the first reaction?
Halogenation. Let me write it here. Halogenation. Because just like with the alkane, we are adding a halogen. So anything from group 7, fluorine, chlorine, bromine, and iodine, they are called halogens. So hence halogenation. And this, by the way, this compound here, when you have a halogen attached to the alkane, we call it a haloalkane. Right? So an alkane with halogens attached to it, it's called a haloalkane. Right? Or in some books or on the internet, you might see halogenoalkane. Right?
It's the same thing for the other one too.
For which one?
Alkene.
No, no, remember, if you have the alkene, remember, if you wrap the alkene with the halogen,
This I meant by turn into alkene.
right? But there are reactions where you get bromine on it too, but not for this one. I mean, at CSEC. All right, so the reason why I pointed this out, because it's not strictly an alkene. If you want to be more specific, when you react alkenes with a halogen, you get a halogenoalkane. All right, it's still an alkane, but it can be more specific. All right. Now, HBr. What happens when we react alkenes with HBr? The same thing is going to happen. Addition. So let me do HBr now. So the white one is hydrogen, the blue one is bromine. Same thing again. So let me just reform the double bond. All right, so This time, the double bond is between carbon 1 and carbon 2.
Sir, can come over the please?
Right?
Yes.
Yeah, so between carbon 1 and carbon 2. Now, when we're doing HBr, I want to point out something, a specific rule. So we have 2 carbon atoms of the double bond, right? How many hydrogen is on this carbon?
2.
How many is on this carbon?
2.
No, how many hydrogens on this carbon?
One.
Oh,
Right. So 2 hydrogen is on this carbon and only 1 is on this carbon. The HBr is hydrogen with a halogen. So we call it a hydrogen halide, right? So this is the halogen, sorry, and this is the hydrogen. So we're now adding a hydrogen halide. In this case, it's HBr. When you look at the carbon to carbon double bond, right? One of the carbons has more hydrogen. So when the double bond breaks, right, we're going to put the hydrogen on one of the carbons of the double bond, and the bromine is going to a next one. Remember we said that this carbon had more hydrogen, right? This one,
yes.
right? So the carbon of the double bond that has more hydrogen, that is where you are going to put the hydrogen of the hydrogen halide. You're not putting it on any random carbon. So let me just go again. The double bond was between these 2 carbons. One of them has 2 hydrogen, the next one only has 1 hydrogen. This hydrogen is coming from HBr. We need to put it on one of them. We put it on the one that has more hydrogen. So which one of the carbons of the double bond has more hydrogen?
Sir, the one to the right.
This one, right?
Yes, sir.
So that is where I'm going to put the hydrogen. And so the bromine goes to the carbon with less hydrogen. It goes to the carbon of the double bond with less hydrogen. All right? And so we have this. So just remember, when you're adding HBr or any other hydrogen halide, you put the hydrogen on the carbon of the double bond that has more hydrogen. So we are always comparing 2 carbon atoms of the double bond, right? So the one that already has more hydrogen, you put the hydrogen of the hydrogen halide on it. So let's go to the board. Let me add the next carbon to this. All right. So here's one. These 2 are the carbons of the double bond, right? Which one of them has more hydrogen? Let me put on the hydrogen.
Sir, the one.
I'm going to label them A, carbon A, B, and C. So carbon C has more hydrogen, right?
Yes, sir.
That means carbon C should get the hydrogen of HBr. So let me draw up the 3 carbons. We know the double bond is going to break, right? So the hydrogen of HBr is going to the carbon of the double bond that has more hydrogen. This carbon has 2, this carbon has 1. That means I'm putting the hydrogen right here. And the Br is coming to this one. Is that clear?
Yes, sir.
All right. So just remember, once it's HBr, if the carbon atoms of the double bond have different amount of hydrogen, put the hydrogen. I just say put the bromine on the carbon with less hydrogen. If that's easier to remember. Now, if it was an alkene like ethene, right? where the carbon atoms have the same amount of hydrogen, then it's okay. You can put it on any one of them. So both carbon atoms of the double bond have the same number of hydrogen, then I can put the hydrogen on either. It doesn't matter. But as long as one of them have more hydrogen, that is when you have to be selective. Put the hydrogen on the one that already has more hydrogen. All right?
So,
So,
sir, what is it called again? The
please repeat.
HBr.
Please repeat.
So, sir, what you said the HBr is called again?
Oh, let me write it. Hydrogen halide. All right. Halide is coming from halogen, which is coming from or referring to group 7. So it's just letting you know that hydrogen is attached to an element from group 7.
Thank you, sir.
All right. So the second reaction is HBr. The first one was Br2. The second one was hydrogen halide. All right, some more notes. Oxidation. So alkenes can be oxidized, and the oxidizing agent is potassium permanganate. So if you react the alkene with potassium permanganate, you are going to get a compound with two OH groups. All right. So each carbon of the double bond, you will put two OH groups on it. All right. So once you react the alkene with the permanganate, the compound you get will have two OH groups on it. And this group is called a diol. So we just refer to it generally as a diol because of the two OH groups. Now, all you need to remember is this equation, right? If you have the alkene and you react it with potassium permanganate, just know that the compound formed, you put an OH group on each of the carbon of the double bond. The next important thing is observation. The potassium permanganate is going to be decolorized. So it will change from purple to colorless. All right? Or you just say KMnO4 solution will be decolorized. So whichever one you want to write. It will change from purple to colorless, or you just say it will be decolorized. All right? So this reaction is oxidation. All right. So after oxidation, we can also react the alkene with water, and that is called hydration.
Sir,
Yeah,
the entire product name diol.
yeah, man. It's just a general term.
Oh.
Yeah. All right, so, right, the next one is hydration. And for this one, we're going to get an alcohol.
Sir, what did you say about when you react something with hydration?
Alkene with water, it's hydration. So the name of the reaction is hydration. So just like when you react it with potassium permanganate, it's oxidation. When you react it with water, it's called hydration. And the product form is an alcohol. So when you react alkenes with water, you will get an alcohol. So if it's eth, and you will get the corresponding alcohol. So if you react ethene with water, you will get ethanol. If it was propene, you would get propanol. So when you react the alkene with water, you will get the corresponding alcohol. Right, I need to plug in back my laptop. The screen might go away for a second, because sometimes it happens when I plug it in. All right, we're back. All right, so the next, we're doing 7 reactions of alkenes. So we did halogenation, addition of hydrogen halide, we did oxidation, hydration. So now we are going to do hydrogenation, which is just the addition of hydrogen. So the addition of hydrogen is called hydrogenation. All right. So it's hydrogen gas that we react our alkene with. And of course, with this one, we get a strictly an alkane, not an alkane, not an right, not an alkane, just strictly an alkane. All right, and the corresponding alkane. So just like when you get the corresponding alcohol, you get the corresponding alkane. So if it's ethene, you get ethane, propene, propane. Right, the next one is combustion. What happens in combustion reactions again? What are the products of combustion?
Carbon dioxide and water.
Right. If it's incomplete, what would you have gotten?
Uh, Carbon monoxide and something else.
And water.
Oh.
Right. Yeah, man. All right. So C2H4 plus O2, you get carbon dioxide and water. So it's just simply to balance the equation now. So how many carbons do we have on this side?
2.
So we have 2 carbons over here, we have 1 over here. So 1 times 2 would give us 2. So we put a 2 in front. On this side, we have 4 hydrogens. So over here, we have 2 hydrogens. So we know 2 times 2 will give us 4. So we put 2 in front. And then over here, 2 twos So that's 4 oxygen plus 2 times 1, that's 2. So we have a total of 6 oxygen. Over here, we have 2 hydrogens. So we know 2 times 3 will give us 6. So we put 3 in front. All right. So combustion is pretty straightforward. So let me just list the reactions again. So we started off with halogenation. And we did addition. With that addition of HBr. We did oxidation. Hydration. What else? Hydration.
Combustion.
All right. And we did the hydrogenation. Right. And combustion. Now, the reason why I said 7 is for the halogenation. I'm going to point it out now. So these are the 6 reactions, right? But halogenation, the products can change if bromine is in the liquid state versus aqueous. All right. So it's 6 reaction, but for this one, it's kind of 2 types of reactions. All right. So just from now on, just keep on practicing your reactions and the reagents. If you can do that, organic chemistry will become easier with practice. All right. So it's all about remembering the different types of reactions. All right. So let me just point out what I want to about halogenation. So let me go back to the alkene. If you react it with aqueous bromine, now on the exam or on any test, if you see aqueous bromine or bromine water, it's the same thing. So bromine dissolved in water, it's a solution. So we say aqueous. So if you see bromine water or aqueous bromine, it's the same thing they are referring to. So bromine, water, or aqueous bromine, it's the same thing it is referring to. So if you use bromine water, what is going to happen, one of the carbon atoms of the double bond will get Br, and the next one will get OH. All right? So if you react the alkene with bromine, one of them get Br and one of them get OH. That is if you use bromine water. If you use liquid bromine, if bromine is in the liquid state, you will just get Br on both of the carbon atoms. Alright? So if bromine is liquid, you put Br on both of the carbon atoms. But if you are using bromine water, one of the carbon atom is Br and the next one is OH. All right, so just ensure you remember this. And so that's it for alkenes. Let us work a question and then we'll close. All right, so we're going to do one from 2014. This is 2014, number 3B. All right, so we have compound A and compound B. All right, quickly, what's the name of compound A?
Alkene.
All right, that's the general, that's the homologous series, but what's the specific name of it?
Sir,
Butene.
One propane.
Right, one
Butene.
propene.
Butene.
Right, one propene. And compound B, what is it called?
Propane.
Right,
propane.
Propane.
all right. There's propene and propane. So it says, describe briefly one test that can be used to distinguish between compound A and compound B. So you have two lines to describe the test. So describe a test that can be used to distinguish between compound A and compound B. Just know which two tests did I identify that can be used to distinguish alkene from alkane.
Sir,
Reaction
could you then
bromine.
and
Oh, I only told you one, but I
Bromine.
should have also told you potassium permanganate. So both the bromine water and potassium permanganate, we use those two to distinguish between alkene and alkane.
sir, is it because when you put potassium permanganate it turned from purple to colorless?
Right? But the alkane, it don't react any at all. So it says describe a test. All right, so simply two lines, the addition, so the addition of whether bromine or potassium permanganate, right? The addition of bromine water, the addition of bromine water to both compounds. And for observation, what will happen?
Sir,
So, right,
So them change colorless.
which one?
sir, the one with reacting with alkene.
Right, so compound. So for observation, so it's a bromine water would be decolorized in compound A, but stay the same in compound B. So for observation, bromine water, I can say compound A will decolorize bromine water, but compound B will not. Alright, so anyone one phase it. Just know that bromine water will be decolorized in compound A, but no reaction will occur with compound B. Alright? Ready again?
Yes, sir.
Alright. So that was 3B, part 1. We're going to part 2 now. So part 2, both compound A and B burning oxygen. Write a balanced chemical equation for the burning of compound B in excess oxygen. So compound B was propane. So we're at B2. So compound B was propane, C3H8. You react it with oxygen, you get carbon dioxide and water. So we have 3 carbons here. How many carbons should be here?
Sir, well,
True, sir.
3, right? So 3 carbons on both sides. Right, we have 8 hydrogens here. 2 times what will give us 8?
4.
Right, so we'll put a 4 in front. And then 3, 2, 6, so that's 6 oxygen. 4 ones, 4. 6 and 4, that's 10. So 2 times what will give us 10? 5. Right, so we'll put a 5 in front. Alright, so that's the balance equation for compound B with oxygen. And you notice in the question, it says burn in excess oxygen. So the excess there means it is complete combustion. If they had said insufficient oxygen, then it would have been incomplete combustion and we would have had carbon monoxide instead. But they said in the question, burning of compound B in excess oxygen. So it's complete combustion. Also, the next question, part B3, it asks for one use of compound A and B. So our alkenes, the polymer of them, we use them to make plastics. And for compound B, we use them as fuels. So alkanes are used predominantly as fuels. The alkenes, we use them to make plastics. So this is asking for one use of compound A and one use of compound B. I'm drawing about compound A. All right, so we react the propene with compound X, and what do we get here? Which molecular series is this?
Alcohol.
That is correct. So the question is, oh, it just identify compound X.
So water.
Right. So, and what is the name of this reaction?
Hydration.
Right. So compound X is water. And the reaction, the name of the reaction is hydration. All right, next question. It says, oh, so this is C. This was C1. All right, this is C2. State the name of compound D and the whole molecular series to which it belongs. So we already said that the whole molecular series was alcohol. Do you know the name? What would be the name of that alcohol?
So propanol.
All right, and which carbon is the OH group on?
The second one.
Right, so do it like the alkene.
2 propanol.
Right,
2.
all right, so the OH group is on carbon 2, so we say 2 propanol. Or you can say propan dash 2 al. Right, so 2 propanol or propan 2 al. So you always tell the position of the functional group. So if it was here or here, it would be 1 propanol. So let me just add in that little part. If the OH group was here, it would be 1 propanol because it count from the end closest to the functional group. Part A of this question was asking about isomers, which we did earlier in the class. Right, so I didn't know what to do with that one. Right, so that was 2014, number 3. Right, so next week we will do alcohols and carboxylic acids. Then the other week, esters, and we finish. So we can work some past paper, some paper, past paper.
You even try the polymers, that the ester topic.
Please repeat.
If you will even try the polymers.
Right, I must say carboxylic acids and alcohols next week, then esters and polymers. Yeah. Then we can start work a lot of past papers for organic chem, and then we'll go to section A with oxidation, electrolysis, and all those stuff. All right.
Yes, sir.
Yes, and the next 2 weeks we should wrap up our organic chemistry. The other week is a straight past paper session. Then we go to section A. All right. So we're going to close here for tonight, and next week we'll pick up again. All right.
Yes, sir.